Starting chapter 2 in Python, there are a lot of important concepts here. Main topics are variables, expressions, and statements, and we start off with values and types. A value is a thing that has a value. That value could be a number, it could be a string of letters, we call strings, it could be a single letter. So, and these values have types. I was just giving you examples of them. So, counting numbers are integers, whole numbers. Single letters are called characters. A string of letters is called a string. Those things are pretty obvious. We call decimal numbers floats. Most languages do. Sometimes they call them decimal, but most of them call them float because of how it's represented as a floating point decimal in memory. If you have a variable or a value, and you're not sure what type it is, you can ask the interpreter. So if you're in console mode, you can just say type, and type hello world yields this answer right here, class stir, which is string, because that is in fact a string. You tell it type 17, or you ask it what the type of 17 is, it will tell you that is an integer, an int. Down here, you ask for type 3.2, it tells you that is a float. Now, you know that type 17 is an integer, but what if you put the 17 in quotes? Well, now it's a string, because sometimes you do need to represent a number as a string. It's not something that you're going to do math on, but maybe it's part of an address. Maybe you have the number part of a street address stored separately from the rest of the street, for example. So if so you need to preserve it exactly as it is, and it needs to be a string. So there you go. And something else that is different from math is that large numbers, we do not store them as values with commas in them. So we recognize this as 1 million, but to Python, this is a 1 and a comma and 3 zeros and a comma and 3 zeros. And so if you tell it to print this, it thinks these are 3 numbers, and it's going to just strip off the extra zeros and say, okay, that's a 1, and that's a 0, and that's a 0. And so it's going to print 1 0 0. So this is the first example we've seen of a semantic error. It is somewhat important to know the difference in the types of errors you can make. If you make an error that the interpreter, in case of Python, or compiler in other languages, make an error that it doesn't understand and it complains about it, that is a syntax error. You have syntactically said something that the language does not understand. Here, something unexpected happened. Python recognizes this, it knows what to do, it prints 1 0 0, but that's not what you expected. That is a semantic error. So that is an error of understanding, the way you understand things and the way Python understands things. Okay, on to variables. Variables are much like you learned in math. There are a few differences. And something else, something very important that it's easy to overlook is the equal sign. Now, the equal sign in Python does not mean equals. It means assignment. This is the assignment operator. So right here, we are assigning the value, and now for something completely different, to a variable called message. Here we are assigning the value 17 to a variable called n. Here we are assigning 3.14 yada yada to pi. So this is the assignment operator. You cannot reverse that. You can't say 17 equals n. So that is something very different from math. If you've never programmed before, that may be a little illogical to you, but that's how it is. It's not an equal sign, it's an assignment operator. You can't assign a variable name to a value. You can only assign a value to a variable. Okay, so once you have a variable defined, you can do something with it. So Python knows that n is 17 already, and you can tell it to print n, and it does. You can tell it to print pi, and it will. The type of a variable is the type of the value. So the type of message is a string because we assigned a string to that variable. Now Python is very friendly in that it is what we call it is weakly typed, a weakly typed language. So you do not have to tell it in advance what type of variable it's going to be. You don't have to say, okay, I want a variable called message and I want it to be a string, and now I can assign that variable a value. It lets you do it all at once, and in fact, you can reuse it. So you can decide that message is now going to be an integer, and say message equals 3, and now message is going to be an integer. Python doesn't care. A lot of languages do. Python does not. So what can you call variables? Now, in math, you want it to be something very simple. You tend to use single letters for the most part, or sometimes you use a few more, but usually you use single letters because you're writing stuff out and formulas get long and you need to save the space, and that is perfectly adequate. Well, in programming, you want to have meaningful variable names. And so we tend to use short words, or occasionally we string them together. And one way of stringing words together in a variable name is to use underscores. Another common practice is to uppercase every word after the first one. So like right here, they said my name. Another method would be to say lowercase my, skip the underscore, and say capital N, lowercase ame. That is another method of doing this. A lot of teachers will insist on a particular method. I do not. Some jobs will insist on a particular method just to be consistent. So it is a good idea to be consistent, but be prepared to be consistent in either of those major methods. Okay, so you cannot have a space in a variable name because then Python thinks it's two separate words and it doesn't know what to do with that. So you can use letters and numbers and underscores. That's it. And it does consider, okay, but you cannot start a variable name with a number. So if you try to do this, so this is going to be a common error that you may get, is a syntax error. If you get an error message like this, syntax error, invalid syntax, and it's pointing at a variable name that you're using for the first time, chances are it's not a proper variable name. And so right here, this is wrong because it starts with 76, and you can't start a variable with a number. Here, it's complaining because you used the @ sign, and you can't do that. And here, it is illegal because class is a reserved word. So this is one of those times when you need to be familiar with those reserved words. So we saw those in chapter 1, I believe, and now here they are again. 33 of them. You can't name a variable one of these things. If you really, really want a variable that's called except, then call it except1 or my except or something like that. Okay. Oh, another very, very common syntax error that you should be looking for if you run your code and you get an error and you can't figure out why, see if you typoed a variable name. Because I'm telling you all the time, you may have a variable called trombone, and then you accidentally type trombones next time. Those are different things. Python doesn't know that you meant the same thing. So that is a very common thing to do. So so be on the lookout for illegal variable names and typoed variable names. Consistency is good. Okay, statements. A statement is an executable chunk of code. So it's something that Python will do something with. So an assignment, so a statement here, print 1. Okay, it's going to print 1. This assignment here, x equals 2, that is an assignment. Python finds a chunk of memory that it labels x, and it stores the value 2 in that. Print x, that is something it does. So an assignment operator is not going to produce output, but it is still doing something. Now, operators and operands. Operators should mostly be familiar to you from elementary school math, plus and minus, and the / for division. Since x is a letter, we don't use that for times. We use the splat for times, and we use 2 splats for exponentiation. And they work pretty much like you expect to from arithmetic. So then it's going to go on about, okay, what happens if you have an integer and a float in some combination? What are you going to get? Okay, the regular division operator is, we are using Python 3, so it's going to use floored integer division, which means if you divide, say, 5 by 2, if you say 5/2, then the answer to that would be, if you did this in 2nd grade or 3rd grade or whenever you do division, it would be 2 remainder 1, right? 5 divided by 2 is 2 remainder 1. It's going to give you the 2. That is floored integer division. An expression is just a combination of values, variables, and operators. So a value all by itself, like 17 or x, that's considered an expression. So it could be a value, it can be a variable. All by itself, that's an expression. It can be something, it can be an arithmetic expression. X plus 17, that is still an expression. If you're in console interactive mode and you type an expression, then the interpreter will evaluate it and display the results. But in a script, that's not going to do anything. It's not executing. So just because you say x plus 1, well, you didn't do anything with it. So right here, probably what a programmer would mean to do is to say, okay, x equals 5. Now let's make that 1 more than that. So you should say x equals x plus 1. Now that doesn't make sense from a math point of view, but remember the equal sign is an assignment operator. So if you say x equals x plus 1, then it's going to take the previous value of x, put it into this expression, x plus 1, come up with 6, and then store that, assign it to x. So if you print x after this, it will be 6. If that doesn't make sense to you, play around with it in console mode for a little while and see what happens. Okay, order of operations. This is exactly the same as it was in elementary school and high school and everything in between. So parentheses have the highest precedence. and they can be used to force an expression to evaluate in the order that you want, or just to make it clear if you think something is not very obvious, what order it gets evaluated. So parentheses first, and then exponentiation, and then multiplication and division, and then addition and subtraction after that. And if something has the same precedence, then it goes from left to right. So think about this one. 2 times 3 minus 1. We're going to do the parentheses first, which 3 minus 1 is 2. And then we're going to go from left to right and say 2 times 2, and we get 4. Here, we do these parentheses first, get 2, and we do these parentheses, and we get 3. So now we have 2 exponent 3. So 2 to the third power is 8, 2 cubed. So here, it's just something times something divided by something, and those are all of equal precedence. So you just go from left to right, but you can choose to put parentheses in to make it make more sense to you. Let's see. Oh, the modulus operator, that's a fun one. So this is the way you force integer division, and you make sure that you're not accidentally doing float division. Okay, so 7 div 3, this is going to be elementary school math. So what is 7 divided by 3 if you're a third grader? It is 2, remainder 1, right? So if you need to know that, 7 div 3, the answer is going to be 2. Okay, so quotient is going to be assigned the value 2. If you need to know what the remainder is, you use the modulus operator, the percent sign. So 7% 3 is going to be 1, because 1 was the remainder there. And you may think, why in the world would I care about that? Well, there are lots of times that you want to care about that. And a very, very common one is to be using modulus 2 to get even and odd numbers. So, I mean, if you print something somewhere in the code that runs your printer, there's going to be something that if you're printing on both sides of the page, there's going to be something in there somewhere that says basically, oh, if this is an even numbered page, then flip the page over before you print the next one. And if it's an odd number, then just print or go to the next page or whatever it does. I mean, but it's going to be somewhere in the code. There's going to be a modulus to figure out what page number they're on. Doing a percent 100 will give you the last 2 digits of a number. Sometimes you really care about that. So, okay, that's pretty much it for math. So now string operations. So the plus operator also works on strings. So what would make sense, do you think, if you had 2 strings? So if you had this string, I wish they hadn't used numbers here. Let's say you have a string, say x equals cat and y equals dog. What do you think x plus y would be? Well, it's not going to be some new critter that's a hybrid of a cat and a dog, and it's not going to turn it into the numerical equivalent of cat and dog. The plus in this case is a concatenator, so it's simply going to return the strings stuck together in the order that you gave it as input. So cat plus dog would be cat dog. Here we have a string that is 100 and a string that is 150. So if we print first concatenate second, we get 100150. Now, if they're numbers, 10 and 15, and you say print first plus second, you get 25. So notice that we're doing more than one step in a single line here. So you could use another variable and say, okay, third equals first plus second, and then print third. And that would be totally fine. But you don't have to do that. Now, sometimes if you're going to use that value again somewhere, you totally want to do it that way, so you don't have to keep repeating calculations. But if this is the only time you're ever going to need to do this calculation, then just stick it inside the print statement. And it will work from the inside out of the parentheses. It will first do this operation, and then it will print it once it finds the value. Okay, asking the user for input. So sometimes you want to get a value from the user from their keyboard. So Python provides you a nice function called input that does exactly that. So when the function's called, program stops and waits for the user to type something until they press return or enter. This is important. The input statement returns what the user typed as a string. So even if they type a number, it's going to be a string, and you can't do math on it. Okay, so you don't want to just do this, because then what's going to happen to the poor user? They're going to run your program, and then nothing's going to happen. And they're going to think, well, it doesn't work. Well, that's because you didn't give them a prompt. So you give them a prompt in the parentheses right here. So name equals input, what is your name? The backslash in here is a line feed return, carriage return, basically. So this is the prompt, what is your name? So the user is going to see, what is your name? And then they're going to answer Chuck. So the program gets to this point, it prints out the prompt, and then it waits until the user types something in, and then it takes this value and stores it in name. So now it's got a variable called name that has the value Chuck, and you can do something with that. New line, that's what I was trying to think when I said carriage return. It's a new line. Yeah. Don't know why I couldn't think of that. Okay, so here we're looking for a number. So the prompt, you can also do it this way. You can have a variable named prompt and give that a string value. What is the airspeed velocity of an unladen swallow? And then you can do your input statement with the variable prompt. So it knows what prompt is because you defined it here. So input prompt, it will spit that out. It will wait for user input to 17. It will store that in speed. Okay, but 17, even though the user didn't enter it with quotes, remember, input is always going to be a string. So now speed has the value quote 17 quote, right? It's a string. But you need to do math on it. So you turn it into an integer with this nifty little function, int speed. But remember, this is an expression. We didn't store this value anywhere. We just said int speed. Now, this chunk of code right here, we're working in the console mode here, interactive mode. So it does actually return something. If you're in a program, this isn't going to do anything because you're not assigning it to a variable. You're just saying it. I mean, you could print int speed and that would be fine. But this is just an expression. It's just an expression here. But now that you can reference it as a number, you can do math on it. So now you can add 5 to the 17, And instead of concatenating, it's going to give you 22. But what happens if you try to do this nifty little int trick and speed does not contain a number? It's going to complain. And we will find out how to handle that later. And that is something that after this program, once you learn how to handle that, I will expect you to always handle it. But we will get to that later. Comments. Okay. When programs get bigger, more complicated, they get harder to read. And people will be coming back later to maintain your code, sometimes many years later. And you will be looking at other people's code and you will really hope that they commented it. Now, a lot of teachers in basic programming classes will insist that you comment every line. I don't. I think it's stupid. So it's, I mean, this is pretty obvious what we're doing here. Compute the percentage of the hour that has elapsed. Percentage equals minute times 100 divided by 60. That's pretty obvious. I would not really expect you to do that comment. This one in particular, assign 5 to V. Well, that's exactly what that says. V is assigned 5. I mean, that is a completely unnecessary comment. I do expect you at the beginning of each program to put in a comment that has your name and the date and the title of the program. And that is where in a big complicated program, you will also put a description of what it's supposed to do. Since these are all going to be fairly simple, I don't expect you to do that. You can if you want to. You can use it to divide up the different parts of the program. You can say, okay, here's where I'm gathering user input. A comment after that, say, here's where I'm doing some calculations. And another comment later saying, here's where we're doing we're done and we're doing the output. That is a very common thing to happen. Get user input, you do something with it, and then you spit out something else. But if you do something particularly complicated, especially if you do multiple things in a single statement, like you're calculating things inside a print statement, you might want to comment that a little bit. So anything you do that you think is especially complicated, give me a comment. So, oh, and I didn't say it because it's just pretty much right here. Anything after a pound sign is going to be a comment. It could be on a line all by itself, or it could be after the code, but anything on that line after the pound sign is ignored. So it will have no effect on the program, and it will only be there to anybody who is looking at your code. So, and then here's just a section on coming up with good variable names. X1Q3Z9AHD is generally going to be a very bad variable name. Pay, hours, and rate, those are pretty good. They're pretty obvious what they mean. I think we've pretty much covered everything in this chapter. Make sure that you know what all of these words mean. Assignment, concatenate, comment, evaluate, expression, floating point, integer, keyword, mnemonic. But you don't have to know that. Modulus operator, operand operator, precedent, statement, string, type, value, and variable. Yep, know all of those. Okay. So exercises. You do not have to do these and turn them in or anything, but the exercises at the end of each chapter, or sometimes in the middle of each chapter, are very useful practice for you. So you should at this point know how to do this, know how to write a program that uses input to prompt a user for their name and then welcomes them. So you're going to write an input statement with the prompt of enter your name and a colon, and then you're going to print hello and their name, the variable name. Here, you're going to ask for 2 inputs, and then you're going to multiply those together, and then you're going to print that out. Yeah, so work through these, and if you don't understand them, then by all means ask me for help, but I think I'm going to stop here.